Now we're going into question 3. Very important kind of question, guys. 3D trigonometry. You guys struggle sometimes, so let's take a look. It says, in the diagram, B, E, and D are points in the same horizontal plane. The moment they're in the same horizontal plane, it means you can work with them in their own triangle without having to worry about weird angles. Okay. AB and CD are vertical poles, meaning they imply these 90-degree angles. Vertical means that if I'm on the ground, vertical pole, 90 degrees. That's all it is. Steel cables AE and CE anchor the poles at E. So we've got our pole, means that we have a cable anchoring it at a point. Okay. Another steel cable connects A and C. So if we had another thing over there, that would be that cable connecting the top. Lastly, it gives you a bunch of measurements. So CE, which is a cable, is equal to 8,6. BE is equal to 10 meters. Angle AEB is 40 degrees. Angle AEC is 70 degrees. And angle CED is 27 degrees. Okay, so guys, just double check that they've put all that information on your diagram, which they have. They've put all the measurements and the degrees. So, guys, what you need to understand, if we had this, we are looking for you to understand that this is a 3D situation. We have the ground, we have two poles standing up, and we have all these cables happening, okay? So all of these triangles are not just flat on the surface like they've been presented to you on your exam. Okay, you need to picture this. You've got the ground, you've got a 90-degree pole, you've got cables anchoring the poles, and then cables connecting the poles. It's all very 3D. So you need to make sure that if you're working in one triangle, you need to know how to translate that information into another triangle. They're not all just flat. You can't just have different angles adding up to each other because they're at weird angles to each other. They're not just flat on your page. Okay. So envisage this image. Imagine the poles, imagine the cables. Make sure you understand which triangles translate into which other triangles. Okay, so question 1. Calculate the height of pole CD. So if we come and have a look here. We're working in this triangle over here. Guys, as soon as you see a 90-degree angle, you must know 90 degrees means that I can use my ratios. Any one of them. Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. And tan is opposite over adjacent. The moment you have a 90 degree in your triangle, you can use any one of those. So we're trying to find CD. In that triangle, it is the opposite to this angle over here, this angle 27. We've been given the hypotenuse, that 8,6. So if we're dealing with opposite and hypotenuse, it is sine. Sine 27 degrees is equal to the opposite, which is what we're trying to find, over the hypotenuse. Okay, so easy peasy. If I want to get CD on its own, I multiply both sides by 8,6, because if I do one thing to one side of the equation, I have to do it to the other side, which means that 8,6 will divide into 8,6, and we isolate CD. On this side, we've got 8,6 times the sine of 27 degrees. This is where it's easy peasy. You just go and stick that into your calculator. So 8,6 times sine of 27 gives me 3,90. Everybody, when in doubt, round off to 2 decimal places. Odds are you're going to get a much more accurate answer. So let's go put that on our diagram, actually. It might help. 3,9. You can say 90 if you want. So now, let's look at the next question. Calculate the length of cable AE. AE sits in this triangle over here. And happy days, we have another right angle triangle. So we can use our ratios. Simple, easy peasy stuff. So if you look at this diagonal, we've got the angle of 40 degrees, which is what we're dealing with. We have BE, which is the adjacent, and we're looking for AE, which is the hypotenuse. Which ratio uses adjacent and hypotenuse? It's cos. So cos of 40 degrees, which is what we were working with, is equal to the adjacent over the hypotenuse, which is what we're trying to find. So if we multiply both sides by AE, we get AE times the cos of 40 is equal to, these two AEs will divide into each other to give me 1, so I get 10. So now, if I want to further isolate AE, I divide both sides by cos of 40. Okay, which means that I get AE, these two will divide into each other, is equal to 10 over the cos of 40 degrees. And that again, you can just plug into your calculator. 10 divided by cos of 40 gives me 13,05. And we know that everything's been given in meters, so just fill in your units. So over here, we've just calculated this side, 13,05. Okay, easy peasy stuff. So now, last question. Calculate the length of cable AC. So let's have a look. AC. Okay, so AC is this cable over here. Hopefully everybody can see the blue on the blue background. Okay, it falls under this triangle here. Okay, guys, what you need to remember is that these angles or these triangles are at weird angles to each other. If I have, excuse me, two poles with cables anchoring them, you need to understand that the triangle we're working in is now doing this. It's got like a weird angle. I can't work with angles around a point or adjacent angles equal to 180 degrees or whatever they're equal to. I can't. That triangle is at a slant based on our poles and the cables and stuff. Okay, so we need to use a rule in this triangle that I can actually apply to the triangle. So let's take a look at the triangle. Is there a 90 degrees in the triangle? Well, the only information we have is that that angle is equal to 70 degrees. There is no 90. So now these cannot be used. So let's redraw that triangle just to try and get it out of our context. ACE. We know that this here is 70 degrees. We have no information about the other angles, but we have 13,05, which we found in question 2, and 8,6, which was given to us. Okay, so if I'm trying to find the third side over here, I have two sides and an included angle. It sits in between them. What rule can I use? Hopefully you guys know it is the cosine rule, which says AC squared is equal to the square of the one other side plus the square of the other side minus twice their product times cos of the included angle, which we know is 70 degrees over there. Okay, so I'm going to just keep working up here because I have all my information up here, so I can just plug it in. So AC squared is equal to AE squared, so 13,05 squared, plus CE squared, which is 8,6 squared, minus twice their product, 8,6 times cos of the included angle. Okay, and because we're trying to find that third side, we don't even need to do any weird manipulation. We can stick all of that into the calculator. So 13,05 squared plus 8,6 squared minus 2 times 13,05 times 8,6 multiplied by cos of 70 degrees. It's going to give me 167,49, etc. Okay, and if you look at it, that number looks pretty big. We've got a 13, an 8, and now we've found 167. Well, if it looks too big, that's because you've forgotten that's AC squared. So if we want to find AC, we need to square root that answer. So while the answer is still in the calculator, you can literally just say AC square root of answer, and you will get 12,94. Okay, so guys, when you get an example like this, search for your 90 degrees. The moment you get a 90, you don't even need to use cosine rule or sine rule, which gets a bit icky. If you have a 90 degrees, use your ratios. Identify adjacent, opposite, hypotenuse. Deal with the ratio that deals with the sides that you need or are given based on the angle that you're working with. Okay. If you don't have a 90 degrees, you need to identify sides, included angles, and see if you need the sine rule or the cosine rule. Then make sure you plug everything into the right value, okay? If you're working with angles, make sure you take the sine of the angle over the opposite side. Make sure you understand which is the included angle. If you guys don't know what an included angle is, if I'm given one side of a triangle, the other side of the triangle, the included angle is the angle those two sides make. There's this angle in between them. Okay, cosine rule always works with the included angle. If you're trying to find this side and you've been given the top, that side, and this angle, it means you need to substitute into the right place. Just identify your angles and your sides, stick them into the right rule, and you should be fine with this kind of stuff.